Let's see. Read us the objective, please, Xavier. Tell your neighbor the concept we're still on. And that's why we don't need a Freire model. You already have this in your notes, and you already know the definition. That's why we don't need the Freire model for system linear equations. Should look something like that. We started applying systems using the video that I took going to get a spicy mocha and and a matcha, something like that. I also gave you a problem-solving strategy to continue using, which is the cubed. Remember that? So like I said, the spicy chai and the matcha. From there, we moved on to sheets of felt and cardstock. Remember that? And then we looked at, I think, in passing, applying it to flowers. From there, we went to rate problems, which were using an airplane. Remember that? We did several of those. And then I showed you how we can apply that to other rate problems, such as the canoe paddling and stuff like that, or a boat traveling on the water, distances with time, and so on. So we're done with all that. Let's crank it up a notch. Copy this one. Example 6. It says, a chemist mixes 20% of saline solution and a 40% saline solution to get 60 milliliters of 25% saline solution. How many milliliters of each saline solution should the chemist use in the mixture? Copy that, and then I'll get started with the setup. Go. All right, once again, let me read it out. Hazel, can you get the lights, please? It says, and Connor, can you leave the door open on your way up? A chemist mixes a 20% saline solution and a 40% saline solution to get 60 milliliters of 25% saline solution. How many milliliters of each saline solution should the chemist use in the mixture? So, to get started, we're going to continue using our acronym, once again, with your colored pens. I'm going to start with blue. I'm going to circle important numbers. What are important numbers? 20% saline solution, so circle that. What else? 40% saline solution, that's important also. Circle that. What else is important? 60 milliliters of 25% saline solution, circle that. All right. With red, underline the question. How many milliliters, bless you, of each saline solution should the chemist use in the mixture? Now, in the question, I want you to double underline the emphasis or the focus of this question or this problem. And it's going to be around this word, milliliters. Milliliters. That's what they're asking for. All right, from there, let's box key terms. A chemist does what? Mixes. Okay, so we're looking at a mixture problem. What do they mix? They mix saline solution. That's important. Box that. And a 40% also of saline solution. That's important. To get, what do they get? 60 milliliters of what? Saline solution. All right. So it looks like here we don't have different variables that we can use according to what they give us because they gave us saline solution all the way through. So will we be able to use S and then S1 and S2? No. We have to use different variables. All right. Let's exclude anything else and let's start drawing our table. So how many lines down, everyone, for systems? 3, 1, 2, 3. 2 across. All right. So, with that said, this one is very similar to the one we started with last week at the beginning of the week, which was the item and cost. What are the items that we're talking about here, guys? Saline solution or mixture of something, right? But instead of cost, now they're talking about what? What is most predominant in the whole problem? Percent, percent, percent. Do you guys notice that? So instead of having dollar symbols, now we're going to have percent. So our setup begins the same. First row right here, we're going to label it item. But for this one, the emphasis in the question was, what are we looking for? Milliliters. So we're going to label this ml. The second one, instead of being cost, we're going to label it percent. Percent. And in parentheses, we're going to label that decimals, or DEC period. Decimals. All right. Are we there so far? Okay, so let's see what they're talking about. See what I'm going to label here. It says, a chemist mixes a 20% saline solution and a 40% saline solution to get 60 milliliters of 25% saline. So how many mixtures does he make, or does she make? Okay, here it goes again. I'm going to read it once more. It says, a chemist mixes, what do they mix? 20% with what? 40% to get 60 milliliters of 25%. So how many mixtures? 2. So we're going to label this first column first mix. And what is the percentage for that one? 20%. So label it here, 20%. Okay? So what do we label the next one? Second mix. And what is the percent for that? 40%. So what do we label our last column? Total mix. And what is that? 25%. All right. So let's go with our item in milliliters. Do we know how many milliliters in the first mixture? What can we label that?
1.
Okay. We could use numbers and variables, but won't we get confused when we start doing elimination? Okay. We can't use S because all of them have S, so what other variable can I use? X. That is correct. So if this one we don't know the milliliters, we label it X. The second mixture, what can we label that? Y. Do we know the total milliliters in the total mixture? That is correct, 60. Everybody see that? Okay. Next, percent in decimal. How do you write 20% in decimal form? 0.20. Now, question. Do we know how many milliliters we use to get that 20%? So what can we label? 0.20 what? X. Therefore, what is this one? 0.40 Y. What is this one? No. What is the percent first? 0.25 times what? Okay, let me go back again. Look at this one. This was 0.20 times the number of milliliters. Since we didn't know, we just wrote X. 0.40 times the number of milliliters, which was what? Y. This is 0.25 times the amount of milliliters, which is 60. So what is 0.25 times 60? 15. Okay, so we already converted that. All right? You see the system now. X plus Y equals 60, which is this one right here. And my second equation is what? 0.20x plus 0.40y equals 15. So, Justin, which variable would you like to solve for? I mean, which one do you want to eliminate? X. So Justin wants to eliminate X, so what do we multiply this first equation by, everyone? Negative 0.20. Distribute. That gives us negative 0.20x. Negative 0.20y equals negative 12. Do we know what to do from there? Yes. Let's see. Finish off solving for y, then from there solve for x, and then wait for me so we can do the statement together. So continue. Copy that and go. All right, let's see. So you cancel the x's, is that correct? We're left with 0.20y equals to 3. And if you got up to right there, okay? From there we divide by 0.20, divide by 0.20. Y equals 3 divided by 0.20. Move the decimal twice, add 2 zeros. 20 fits into 31. Subtract that 10 into 100 5 times. So this is 15. Hands if you got that. All right, before we continue, y equals 15. Look at it. Don't say it out loud. What does that mean? 15 what? Don't say it out loud. Just think about it. Talk it over your neighbor. What is 15? What is that? All right. Andrew, 15 what? What did your neighbor say? Marco. Milliliters. Label that. That is correct. ml. So, what do we do with that to find out the other mixture in milliliters? Pedro. X plus y equals 60, but instead of y, we substitute the 15 in there. That is correct. X plus 15 equals 60, minus 15. Therefore, X equals 45 what? Milliliters. All right. So let's look at the question. How many milliliters of each solution should the chemist, saline solution should the chemist use in the mixture? So let me write my statement. The chemist mixes. All right, so I'm going to start with the milliliters. 45 milliliters of the, what does the 45 correspond to? What percentage? Guys? It corresponds to which one? The first mix, which is what? What is the percentage? 25 milliliters of 45 milliliters of 25% saline solution, comma, and what else? There it goes again. The chemist mixes 45 milliliters, which is this one, of it wasn't 15, of 20% saline solution. 20%, which is this one. 45 to the 20. And what else? 15 milliliters of 40% saline solution. 10Q. That's it. So if you notice, after we write the system, the elimination process we know. So what would be the challenging part of this problem? The setup, right? So let me recap on the setup. 3 lines down, 2 across. Instead of being item and cost, now it's what? Item and percent. For the columns, the first column is the first mixture. You put the percent, second mixture, the percent, and the total mixture, the percent. Since we didn't know the milliliters for the first mixture, we wrote X. Since we didn't know the milliliters for the second, we wrote Y. But we did have the total milliliters for the total, which is 60. From there, we wrote the percentage as decimals, 0.20, but since we didn't know where that came from, we put times the missing milliliters, so times X. This one times Y, and this one times 60. So 0.25 times 60 gave us 15. So my two equations are X plus Y equals 60, which is right here. 0.20X plus 0.40Y equals 15, which is here. And then we just chose which one to eliminate and solve for the rest. Are we there? Okay. So, show me with your fingers how come through you are so far up to right there. I got some 3s, 4s, 3 4s, 2, 3 4s, 3 4s, 4 4s, 6s. Okay. All right. So turn your paper over. I'm going to give you one so that you can do the setup by yourself and see how you do without looking at your notes. Okay? Here we go. Let me get there. All right, here's the problem. Example super Q. Don't copy this problem. You're going to continue from the table, but let me show you what they give us. It says, a chemist has 25% and 50% acid solution. So what are the mixtures? 25% and 50%. How much of each solution should be used to form 200 milliliters of 35% acid solution? So look at this one. By the way, what are these called? Beakers? Okay, so what would I label this one? This is my first mixture, is that correct? This would be my what? Second. And the first one is 25%, the second one is 50%. So what do I label this one? Total. And the total is 35%, but it's also how many milliliters? 200 ml. Okay, so with that information, set up a table and see if you can set up the table without looking at your notes. Try and do it as much as you can without looking at the notes. Ready? Go. And for you that are following on the video, copy that and see if you can do that by yourself. Go. Oh, I'm sorry. Hold on. I forgot. Let me get you guys started.
Let's get the lines going here, boys. At least we have more than one line.
There you go. All right. Continue.
Can you go farther?
Yeah.
Oh, that helps us so much.
Is that good?
Yeah.
Okay. Let's see.
Too calling.
Oh.
He's still gone.
Should be just about done setting up the table at least. Okay. Luker, what do I write here? Item, and what else? Milliliters, okay. What do I write here? Hands, have you got that for that row? That is correct. Pass someone. How about the second row? Percent, and that's in what? Decimal. All right, so before we write that in, what do I label this column? Ethan. Okay. Which is how much? About this one. %. And this one? Third. Total mix, which is 35%. Okay, now with that, Andrew, what do I write here? 0.25, which is from the 25% in decimal, and then, hold on, we're not done. Remember, this one is a combination of these two, but in decimal. X, this one, 0.50y, and this one. And if we got up to right there, that is correct. And 200 times 0.35, that's 70.
Oh, I did not know that. So now I do.
Hands if you got that by yourself. Okay. So, do you see the system now? Okay, so we get x plus y equals 200 and 0.25x plus 0.50y equals to 70. So with that said,
Let's do y.
Cooper, which one do you want to eliminate? The what? The y. All right, so we multiply this times what if we want to eliminate the y?
Negative 0.5.
Negative 0.50, distribute all the way, so this is negative 0.50x, negative 0.50y equals to, what is half of
100. Negative 100.
negative 100, okay? I'll give you guys a head start so you can finish off. Copy that in, go. All right, let's see, continue from there. Isabella, what do I do from there? Cross out the y, and we're left with equals to. And if you got us to right there, that is correct. And then we solve for x. Divide by negative 0.25, divide by negative 0.25. Negative divided by negative is a positive, so this is x equals 0.25 into 30. Let's see, 30 divided by 0.25 does not fit in there. Move this twice, add to zeros. Fits in there once. 25, subtract. That's 5. Bring down the 0. Fits in there twice. That's 50. Bring down another 0. 0. So it's 120 what?
No.
Milliliters. Hands if you got that. Okay, good. And then what do I do from there? Elena. Okay, tell me what to write. X plus y equals 200. And substitute the x, which is 120, plus y equals 200, minus 120, minus 120, y equals 80. 80 what? Milliliters. All right, yes. Then you made a mistake. Yeah, if you said you eliminated the x. So if you distribute negative 0.25, then you should have gotten, let's see, 0.25x plus 0.50y equals 70. And then you distributed negative 0.25. So it's negative 0.25x, negative 0.25y equals negative 50. You saw the mistake right there? It was right here on the 50, right? Yeah, so be careful with those. All right. So with that said, what is our statement? So let's see. How much of each solution should be used to form? Okay. Justin.
If you play advertising.
The chemist mixes the chemist mixes 120 milliliters of focus. What does the 120 milliliters correspond to? Of 25% acid solution, comma, and 80 milliliters of 50% acid solution. 10Q. Hands, have you got that? Okay. Show me the fingers how comfortable you are so far with these. 4 5s, 4 5s, 3, 4 5, 4 5. Okay. All right. So, copy this next one, please. Example number 7. You do need to write it down, please. Go.
Whoa.
It says, suppose a pharmacist, example number 7. Suppose a pharmacist wants to get 30 grams of an ointment that is 10% zinc oxide. By mixing an ointment that is 9% zinc oxide with an ointment that is 15% zinc oxide, how many grams of each ointment should the pharmacist mix together? In this case, are they asking for milliliters? No, they're asking for what? Grams. That is correct. Everybody done? How about now? Okay, so as you're finishing copying that, so home plate for tonight is problem number 7, which is the one you're just copying. And pages 326 through 327, but only do numbers 17 through 23. 23.
Number 23.
All only. Yay. All number 17 through 23 only. Maybe.
Do you know what the Super Bowl is?
Is everybody done with that? All right. So once again, make sure you finish this one at home, the word problem, the setup, and all that time. See if you can do that without looking at your notes. For numbers, pages 326 through 327, number 17 through 23, I think there's 1 or 2 problems with solving by substitution, 1 problem for elimination, and the rest of the problems are solving by graphing the system. I want you guys to get practice of that before we get into the next section. All right. Okay, have a good one, guys. Enjoy your home play. See you guys tomorrow. Bye.